So over here, we're looking at using rules of inference to show that for all x's, p of x or q of x, comma, for all x's, not q of x or s of x, and another one for all x's, if r of x, then not s of x. And finally, the last premise, there exists some x for which p of x is false. If all of these premises are true, then I'm trying to conclude that there does exist some x for which r of x is true. Okay, how would I proceed here? So what I can do is, if I start from my existential quantifier, which is this piece over here, which claims that there is some x out there, there's some x out there for which p of x is false. Now, I don't know what this x is, but there's some x out there, and let's just assume, let's just use a variable c to represent the x for which this entire box becomes true, and that x happens to be c. You're going to use the variable c to indicate that that's the x here. So here's my universe. Here's the universe of all x's. Okay, and there's some element out there for which not p of x is true, which happens to be c. So let's say not p of c. Okay, and moving from here to here, I have made use of existential instantiation. Instantiation. Okay, now if I look at my next premise, says for all x's, again from this domain, I have the statement p of x or q of x. Okay, so this piece over here, or this box in yellow must be true for every x chosen from this universe. Let's go and choose this point here, which happens to be c. So it must be true for c as well, which means that p of c or q of c must also be true. And what I've done over here is basically I've used the idea of the going from here to here. I've used universal instantiation. And what I also can conclude from this piece is that because this piece over here is true, not of p of c is true, it means that p of c must be false. And if this is false, and for the entire box to be true, q of c must be true. And moving from here to here, I've used the idea of disjunctive syllogism. Disjunctive syllogism. Oh, my spelling's horrible today. Syllogism. Okay. Now let's look at the next premise over here. The next premise over here, again, let's use orange now. The next premise over here is that for all x's, what I have here is not q of x or s of x. Okay, what can I do from here? Well, again, I'm looking at this entire universe of x's here. I'm going to choose this point over here, c, for which this statement will be true. So this is not q of c or s of c. Now, I know that q of c is true, meaning not q of c must be false. If this is false, then s of c must be true for this entire box in orange to be true. Okay, so just to be clear, moving from here to here is my universal instantiation, and then moving from here to this piece is my disjunctive syllogism. Okay, now let's use the next premise. The next premise here is that for all x's, I'm going to put it over here. For all x's, what I have is r of x. If r of x, then not of s of x. Okay. Now, if I were to use the same point c, because this is true for all x's, let's just use one such x which is C here. So I can use R of C. This is universal instantiation, which means that this entire statement is true. If the entire statement is true, what I can now do is I can write the contrapositive. If I write the contrapositive of this statement here, is going to be S of C. If S of C, then not of R of C. Okay, so moving from year to year is the contrapositive. Now I know that this entire statement is true, but from this entire statement I also know that S of C over here is true as well. So if S of C is true, if S of C is true, then using modus ponens, I know that not R of C must also be true. And then finally, because not R of C is true, that means there is some X out there. There is some X out there. I can use existential generalization saying that there is some X out there for which not of R of X is true, which is what I really want to get at in this problem.